Good day, everyone. Welcome to today's presentation, Overvoltage Protection, Surge Protective Devices, brought to you by Electrical Contractor Magazine and Electrical Safety Foundation International. My name is Colleen Beatty, and I'm the senior editor here at Electrical Contractor Magazine. On behalf of the magazine and NECA, I'd like to welcome you all and thank you for attending. So before we get started, just a few housekeeping items. First, please note that today's presentation is being recorded and you'll receive a link to that after the webinar is over. So if you miss anything or you have to leave early, that's totally okay. You can come back anytime and watch the recording when it works for you. The audio for today's presentation should be coming through your computer speakers or headphones. But if you have any technical difficulties, audio or otherwise, you can submit those through the Q&A panel, which is on the bottom left of your screen. And of course, we encourage your participation in today's webinar, so please send us your questions. You can submit them at any time during the presentation using the Q&A module, again, on the left of your screen, and we'll have time at the end of the webinar to answer them. There's also a quick survey that's going to pop up after the webinar is over. We hope you'll spend a minute to answer some of those questions to help our sponsor. And you can also fill it out sooner if you really like. You can just click the icon at the bottom of the screen that looks like a little clipboard. So with all of the way, I'd like to give a warm welcome to the moderators for today's panel discussion, Brenner, who is president of ESFI, and Mike Johnston, NECA's executive director of codes and standards. Welcome, Brett and Mike.
Welcome to the webinar provided by NECA and ESFI on overvoltage protection and surge protective devices. As we kick off this webinar, there will be a Q&A session immediately following, where we'll be able to answer any questions that may come up during the webinar. And we owe a special thanks to Electrical Contractor Magazine for sponsoring the event, number one, and broadcasting the advertisement of this webinar to its large audience. Thanks for taking the time to be with us today. We have a fine group of panelists that we'd like to introduce along with ourselves before we get started into the content. First of all, my name is Mike Johnston. I'm the Executive Director of Safety for NECA, and I also serve on the NEC Correlating Committee and the NFPA Standards Council. And two of our panelists are joining us from NECA's Codes and Standards Committee today. Kyle Krueger. I'd like Kyle to say a few words as we get started. Kyle?
Thank you, Mike. Name is Kyle Krueger. I work for the Milwaukee NECA chapter. I serve on Code Making Panel 3 and NFPA 72's Correlating Committee through the NECA National Codes and Standards Committee. And happy to be here and participate.
Thanks, Kyle. Thanks for taking the time to be with us. And also we have Nathan Phillips of Integrated Electronic Systems Incorporated. Nathan, you want to say a few words as we get started?
Yes, thank you, Mike. I'm a firearm contractor in Eugene, Oregon, and I'm also chair of NEC Code Making Panel 10 and an alternate and past chair on Code Making Panel 5 and a longtime NECA member, and I'm happy to be here today. Thank you.
My name is Brenner. I'm the president of the Electrical Safety Foundation International. We're happy to co-produce and host this webinar with NECA. And we have a couple of folks that we invited to participate as well. I want to introduce Jack Klaus from Maxivolt. Jack, if you can say a couple words about your background to give some perspective to folks, please.
Certainly. Thanks, Brett, and thank you all for inviting us. So I work for Maxivolt. We're a longstanding member of NEMA. I currently serve as the chair of NEMA's Surge Group's Industry Development Committee.
All right, with that, I'll hand it over to Keith Waters with Schneider Electric. He's our final panelist. Keith, can you say a couple words about your background and expertise, if you don't mind?
Sure, Brett, thanks. So my name is Keith Waters. I'm a industry standards manager with Schneider Electric. I serve on the NEC Code Panel 3, Code Panel 11, and I also am a member of NFPA 79's Technical Committee.
Okay, great. And with that, I'll hand back over to Mike, and he'll go through today's webinar objectives. And we're trying to keep this as conversational as possible. Obviously, a lot of us are remote on this process, so bear with us. But I think you'll have a lot of great information to take away from the webinar, and we're going to have some time for Q&A at the end of this. So, Mike, I'll hand it back over to you to kind of run through the objectives for today.
Okay, thanks, Brett. And it's we intended to set this up as more of a conversational approach and setting for the panelists, so we appreciate them being here. And for our objectives, we're going to take a look at what a surge is and look also at the sources of surge events to help folks understand what we're trying to accomplish, and take a look at the importance of surge protection. Bigger emphasis is being placed in this area for good reason, and we'll get into those details a little bit, and also help differentiate between what constitutes a surge arrestor as compared to a surge protective device, and look at the need for surge protection in dwellings and beyond dwelling units. And we'll also discuss the importance of surge protection as it relates to a fire alarm system or another type of alarm system. And there was a survey conducted by Electrical Safety Foundation International, and that information is important to share as part of this webinar. So some of those survey questions will be presented and the results that were obtained from that. And then we'll look at a timeline from about the 1980s to present on what happened to the NEC. The NEC is evolving in this area to expand requirements for surge protective devices in multiple articles, and we'll take a look at those rules and that timeline.
So we'll kick it off with our first question and asking, what is a surge? And I'll do my best. I'm not the best subject matter expert on this, but I can give it a good shot. But basically, a power surge is a brief overvoltage event that they can damage electrical devices as common cause for failure of electrical equipment. So surges can damage and reduce the lifespan of heating and air conditioning systems, washers, dryers, water heaters, ranges, refrigerators, lightings, entertainment systems, and the list goes on. And I think some of the things that we really kind of want to highlight is the fact that a lot of times we take for granted everything in our house that, just runs off electricity. We don't realize how many important components are somehow run by a computer or have something that's managing those systems within, ranges and refrigerators with TVs in them and smart homes and the like. And when we see something to $15,000 to $20,000 worth of items in a home that can be affected from surge, it really starts to put things in perspective to say, what can this do to my home, and what can this do to some of the most expensive items in my home and appliances in my home, and how do you really protect those devices? And what we found as we started to get in and ask some of these questions is a lot of people were very confused about what they thought a surge was and what they thought they were being protected by the specific devices.
And if I can just add to that a little bit, the NEC first started addressing surge protection as a transient voltage surge suppressive device. And TVSS was the acronym, and the NEC moved off of that after a few cycles. But if I can add to Brett's comment, he's absolutely right. But the question about what is a surge and what are we talking about here, it's those transient voltages that spikes and dips and that may appear, and also in the frequencies you can have swells and sags, but the most common really is a spike and a dip. And if we're dealing with an AC circuit, say 60 hertz, it's the circuit is operating and flowing at 60 cycles per second. That means it's changing in amplitude and direction 60 times a second. And so those transient voltage spikes and surges happen within the waveform. So while you don't see it, you don't see what's happening, that those changes and fluctuations and those spikes and dips can impact sensitive electronics and can actually end up causing damage to equipment where it will no longer operate, especially electronic type of equipment. So that kind of completes the loop. We didn't want to get too technical on that, but I think it's important for the audience to understand that we're talking about things that happen to the waveform that can cause damage.
So with that, I'd like to show you a quick video that we produced that kind of talks about surge, some of the after effects of surge, and some of the symptoms that you might see.
Critical infrastructure depends on the reliability of electrical and electronic equipment. Ranging from medical services to IT and our nation's transportation system, it is imperative these systems remain operational. On average, a typical building experiences surges up to 150 times a month. While lightning and other external systems result in a significant number of surging events, 60 to 80% of surges are created within a facility. These surges are often the cause of cumulative damage to electronics. Surges can damage or shorten the life of expensive electronic equipment.
So two questions arise. What kinds of products or equipment have electronic controls? And do you know what can cause a surge that starts within your home or place of business? And if we take a look at the slide, you can see a few different sources that cause surge events. And I just like to say up front on this is to start, you have external sources, you have internal sources, and what I'm talking about is external or internal to the facility's electrical power system. And then you also have natural sources, such as lightning or those types of events that can create surges. So those are some of the primary sources. And to sum it up very simply, switching operations on the utility side, switching of loads within a facility can cause inrush currents and result in surge events within the facility, even downstream from the service equipment. So there's a few different sources. The majority of the sources that folks are concerned with are internal sources to the facility, although the external sources are very common, and of course lightning and other natural sources are always present. So Jack, can you tell us why it's important to protect from transient voltages? Why is that important for us in today's world?
Certainly. When ESFI released these results, I'll be the first to admit that a lot of folks in the field were a little curious about that 34% of unplanned outages are caused by power surges and misoperations. But let me unpack that for you. The days of electromechanical operations are gone. Even our LED lights are running on microprocessors. And so we've added integrated circuits into our entire operation, from our LED lights, our drives, our motors, and the list goes on and on. So whether it's a smart home or it's a Tesla factory, we're adding what they call Industry 4.0. And so we have to realize that the sensitivity of this modern equipment to transient voltage is much tighter. And therefore, you're seeing more issues from transient voltage and causing unplanned downtime. And so why is it important? Obviously, every industry is different, but they all want to operate as efficiently and as effectively as possible. And if your operation is now dependent on a 2-cent part coming from the lowest bidder on some circuit board, you're going to have to mitigate that risk, or you're going to be in the 34% here suffering downtime. And again, it's not just equipment failure, and this is what opens most people's minds up. It's also misoperations. Going to reset a PLC for an unknown reason. Well, your operation shut down and you still have downtime. So I think ultimately the most important thing I can convey is you can't look at your operation in a traditional sense of electromechanical. You've got to look at it that everything has a computer in it, and it's all sensitive to transient voltage now. Obviously, respondents from this survey have a good experience seeing that SPDs do have a positive impact on reducing that downtime. And again, these are repetition of the previous infographics, but the key thing I want to call out here is that really bolsters this point of view is that 78% of surges, misoperation failures, were from equipment that were in service in less than 5 years. So your newer equipment is causing the majority of your downtime. And again, it's not just the failures, it's also the misoperations.
We talked about surge protective devices, and we also have another type of equipment that's referred to as a surge arrestor. Can we help the audience understand and differentiate between the two? Kyle, do you want to weigh in on that?
Sure. Thanks, Mike. So surge arrestor versus surge protection device, or SPD, both are going to be used to protect from transient voltages. Really, the key differences are performance and then application. With surge arresters, those are typically used, or the common applications are utility side or protecting electrical distribution systems. They're not really intended to protect some of those solid state electronic type equipment that were talked about in the previous slides. Surge protection devices, or SPDs, really are those devices that are more designed. They have lower let-through voltages. Some of the common applications for those are whole house protection, branch circuit protection, or even specific equipment protection. They have monitoring capabilities, a little more smarter of a device, internal fusing and filtering capabilities, and then a longer lifespan. Certain manufacturers will say that their devices will last 25 years, maintenance free. So again, those are some of the key differences.
Hey, Kyle, can you go through and tell us, some of the different types and classes of surge arresters and SPDs to kind of explain that a little bit further? Tell us what's in the marketplace.
Sure. Surge arrestor types, there's 4 different types. Secondary type, it's going to be under 1,000 volts. Distribution type, 1,000 volts to 36 kV. Intermediate type is going to be 3 kV to 120 kV. And the station class type, 3 kV to 684 kV. The distribution type itself has 3 classes in it. Inside that distribution type, the 3 classes are light duty, normal duty, and heavy duty. With the normal duty and the heavy duty have a little, the normal duty has a little bit higher fault current withstand rating. The heavy duty, obviously, like it sounds, highest of the fault current or withstand ratings and used in a higher lightning or heavy lightning areas. For the SPD devices, surge protection devices, typically the ones that you see are the types 1, 2, and 3. Type 1 is permanently installed ahead of a service disconnect. Type 2 is permanently installed on the load side of service disconnects. And then type 3 would be cord and plug connected type device, like a plug-in surge protection power strip type device is typically what we see in a type 3.
So Keith, can you kind of tell us what's available in the market for SPDs in the residential or home space?
So as we look at what's about to occur next, let's think about surge protective devices in the home. And why would you need a surge protective device in your home? So according to the National Electrical Manufacturers Association, or NEMA, the average home has about $15,000 worth of equipment that could be damaged by surges. An example of this could be your TVs, stereo equipment. I can give you a personal example. We lost the controls on a clothes dryer. We had a surge situation that occurred, and now I'm having to replace the dryer because of all the electronics that smoked on it. So what's been done as part of the National Electric Code to help protect this equipment? So in the 2020 National Electric Code, there was a new proposal and requirement placed in for Article 230.67 for dwelling unit services. And in this new requirement, you can use a Type 1 permanently connected SPD, as Kyle talked about earlier, or you can use a Type 2. The Type 1 can be used on the secondary of the service transformer or line side of the service disconnect. The Type 2 would be on the load side of the service disconnect. So you can do either one of those ways of doing it. But this new requirement has been put into place for dwelling units, both for single-family and multifamily dwelling units, to be a way to protect your home from the surges that we've been talking about.
Yeah, thanks, Keith. In addition, with all those electronics in appliances and so forth in the dwelling, there's also electronics integrated into some systems and equipment that are installed in dwelling units, such as fire alarm systems, smoke alarms, a single station or multiple station smoke alarms, and other types of electronics that are actually part of the wiring in the home. And those are systems that are vulnerable to surge events and actually can result in safety problems if there were failures on some of those systems, especially the alarm systems that are monitored by the local fire departments.
So yeah, Mike, thanks. Those were very, very key there, especially those alarm systems, because the other areas that, have electronics that are protecting the home and the wiring, whether it be from fire or electrocutions like AFCIs and GFCIs, these surge protective devices also would help protect those electronics as well.
So one other thing I like to add is one of a home's most expensive assets is going to be its HVAC systems. And with the government requiring lower and lower SEER ratings, HVAC manufacturers have been adding technologies, again, integrated circuits, solid-state devices, to help get to those new requirements, which, again, as I mentioned earlier, those devices are much more susceptible to misoperation and failure due to transient voltage. So just to kind of wrap all this up, everything that you're adding to your home, even if you don't have a full-fledged smart home, just realize you're increasing your home's sensitivity to transient voltage events. And the code is obviously spot on when it comes to safety, but there's also just the actual cost of replacing these items and the frustration.
So Nathan, as a fire alarm contractor, how do you address surge protection for those systems that are installed?
Well, Mike, we mostly do commercial and institutional fire alarm systems. We do a little bit of residential, but I think our experience applies to these home systems that we've been talking about for the last few minutes. What we've found is that in the last few years, our distributors have started to include an external type 2 SPD with any order of a system panel. So you can tell by that it's starting to become something that the industry is wakening up to, is the need for this protection on these types of systems. When they don't include it, we purchase it separately. For equipment that's supplied from a Class 2 power supply, like a plug-in transformer, we typically interpose a Type 3 surge protected plug strip or similar device where we can to protect those systems. We know that many of the products that we purchase are manufactured with internal surge protection of the MOV type, which is integral to the device, but because of the sacrificial nature of MOVs, we don't consider those to be adequate for the protection of this type of system. So on our typical installation, we have the electrical contractor provide the SPD that we provide. We have them install it in the line ahead of or immediately adjacent to our control panel or power supplies for all of the systems that we install in fire alarm access controls, surveillance cameras, intrusion alarms, and similar systems. Where our circuits extend beyond buildings, we provide protection as required in Article 805 of the NEC. And in some cases, we will even install surge protection on individual fire alarm, SLC circuits, data circuits, notification circuits, or for camera, alarm detection devices, or access control devices. So we can provide protection ahead of the panel and also down to the circuit level. We're located in the Willamette Valley of Oregon, which is a very low lightning area, so lightning cause surges are not a particularly significant problem for us, but as we've learned today, there are many other causes of surges that make this kind of protection necessary. And of course, for folks in higher lightning areas, it's even that much more important.
What should electrical contractors or facility managers be aware of or install on the upstream side of an alarm system to provide additional protection? There's a lot of owners and a lot of facilities out there that are legacy facilities. They've been in place a long time, and surges aren't going away, and they may have not put surge protection in upon the initial construction or installation of the electrical system. So how should contractors and facility managers approach this, in your opinion?
Well, our view is that the SPD that we provide at the panel level is kind of like the last level of protection. It's last hope, and that there should be robust protection installed at the service entrance, either a type 1 or type 2 protection. And then if there's a distribution panel or more than one distribution panel between the service entrance and our control panel, we'd like to see an SPD provided at each additional level of distribution, so that, and then of course finally the SPD that we've talked about before provided at the load, so that there's a network or a tiered approach to protecting from these surges, because we know that any surge protective device in the system is not 100% effective. We also pay close attention to proper grounding and bonding to comply with Article 250 of the NEC and to stabilize voltages. And most of that grounding and bonding is done by the electrical contractor at the building electrical distribution system level. And then we make sure that we bond and ground our equipment properly. However, we find that not all of our equipment that we install has provisions for terminating an equipment grounding conductor, as it is connected to the load side of a Class 2 transformer, which doesn't have a grounded conductor. So Mike, maybe you can better explain how the network or tiered approach provides optimal protection for these critical life safety systems, as well as other utilization equipment inside a facility. Thanks.
Sure. I'd be glad to. It's always recommended by those trying to provide protection using surge protective devices to install multiple levels. In other words, at the point of entry of the service, it's really, as Nathan correctly indicated, that's your first line of defense. And that's going to help protect against some of them external events that can get into the building's electrical system. So it serves at the service equipment as a first line of defense, but down at the point of utilization, whether it's a fire alarm system or another type of equipment with electronics, having a surge protective device at that location provides another level from what happens external to the facility, but also what happens internal to the facility between the service equipment and the equipment you're trying to protect. So the ultimate protection is achieved by using multiple levels of surge protective devices, and those that manufacture those devices often recommend an analysis be done, scoping and recording the waveforms of the power providing electricity to a facility to kind of determine levels of protection that might be needed. Like Nathan said, up there in Oregon, it's a less likely event to happen, but you get down into an area like Florida or in Texas. There's a lot of natural events that go on that you want to protect from, and whatever's going on inside a facility certainly generate those events. So the two levels work that way, providing protection from internal events and external events.
I would like to add also, Mike, that when we talk about residential systems, that the code required surge protective device at the service entrance, again, is just the first line of defense, and that what homeowners ought to do, just like I've done, is provide high quality type 3 surge protective devices at the loads, so that just like where I'm right now, sitting in front of my computer in my living room, my computer's plugged into a surge protective strip that is not a cheap one, it's a good one, and that provides additional protection within this facility.
One thing I'd like to add is just to add a little bit of clarity about, why is IEEE recommending a cascading protection system? Everything we've heard so far is correct. There's the voltage transformation piece, I think, is critical, especially when you start getting into industrial and commercial. Just by physics and the nature of the products that our industry manufactures, when you have, let's say, a 480 volt service entrance and you're going all the way down to a 12 volt control, there's no way that 480 volt surge protector is going to be able to step down that transient to what we call the immunity level of the 12 volt circuit. And so there's actual, it's not a good analogy, but it works. It's like saying I'm going to put a 500 amp breaker on my service entrance and I'm done with my current protection. I don't need to do anything else. It just doesn't work that way. Transient voltage has to be looked at a individual specific level based upon what you're trying to protect.
Great discussion so far. One of the things I wanted to bring up, ESFI and NECA teamed up to do a surge survey to find out misnomers that might be out in the marketplace, misunderstandings, and basically try to figure out what do people know or don't know about surge protection and the levels of surge protection and the devices. And so we came up with and created this quick video to kind of tell you some of the findings that we found. So let's play that for you real quick.
A recent survey of facility professionals revealed mixed results on the knowledge of surge protection. Only surge protective devices, also known as transient voltage surge suppressors, protect against power surges. Fuses and breakers, GFCIs, wiring, low-cost interruptible power supplies, and typical power strips do not. A recent study found that 79% of facility owners estimated that installing surge protective devices would significantly reduce downtime or equipment failure. Install these devices to protect your...
Additionally, one of the things we created was a pretty detailed infographic, and we're going to break this apart and tell you some of the key findings that we had. But let's get into the questions. So Keith and Jack, I'll tee this up for you. So what are the majority of people who responded to the survey think the cause of their surge issues were and where they occurred? Can you provide some feedback on that question as well as things that you're seeing out in the field?
So Jack, I'll go first. What I found fascinating from the survey is that most people view that the surge event as happening from outside of their facility, right? So whether you're talking about lightning, which there are people that think the only surge out there is lightning, right? But you have lightning, switching of loads like capacitor switching or bad connections, or a car runs into a power pole and the power line drops and you get a surge in a different part of the area. So what I found interesting is that most of the respondents felt like it was something that wasn't within their facility. It was something going on outside their facility. And as we've talked about before, that's not true about where all of this different surges come from. And maybe I'll let Jack speak to that. So, thank you.
Keith, I completely agree with what you're saying there. And we see that in the field all the time. It's always, and it makes sense because a lightning event happens or the proverbial car hits the telephone pole or whatever, and then you immediately see a failure. Whereas these internally generated transients, they're harder to track, and we call it the death by 1,000 cuts. It's not like when that motor kicks on one time, it's going to knock out your fire alarm panel. It takes time for that to happen. It's death by 1,000 cuts. It's slowly chipping away at the dielectric string at the weakest component or weakest place on that board, or slowly chipping away at the insulation on your windings. So eventually you have a failure. But we don't want to forget misoperations are happening all the time. And typically those are caused by these internally generated transients. So yeah, I agree exactly what Keith is saying. When you start looking at this in more depth, one of the things that really interested me was, so the vast majority of these facility professionals, state that they're extremely familiar with voltage surges. And so the vast majority are saying, yeah, we know what they are. But then you come down later and you look at where they're installing their surge protection. I think it reinforces what Keith just said, is that they might have a general idea of what it is, but they're really not grasping that their own facilities are causing the majority of their issues as it relates to transient voltage. And I also think that's why you saw earlier that 34% of downtime was caused by transient voltage failures or missed operations. It's because facility professionals, trust me, in the field, we're starting to see more and more people become aware of this and start to mitigate it. But it's been a long time coming. So I think the best thing that people watching this can take away is that the majority of your efforts, if they're limited, should be focused on internally, not necessarily externally.
Great insight. So Keith and Jack, what does an SPD actually protect against and what does it not protect against? I think that's what we found in the survey that people were really confused about. And that's much the job that the folks on this webinar want to get the information out. But what are we seeing out in the field in terms of responses and things you're hearing back from your customers in terms of what they do and what they don't do? Maybe you could put out some of those misnumbers that might be out there.
Well, I mean, it's real simple. SPDs protect against transient voltage. There's some filtering capabilities in some of the devices, but ultimately, you're purchasing an SPD to protect against transient overvoltage. It doesn't protect against temporary overvoltage. It doesn't protect against sags. It doesn't protect against swells. But here's a key thing that a lot of people miss. The vast majority of those other power quality incidents have an associated transient voltage with them. If you get a sag in your system, you're going to have a transient voltage event associated with that sag. And I can tell you, we have an experience with a wafer fab manufacturer in the upper Midwest. And they were having sag issues. They had a power quality monitor installed in their facility that was recording the sag issues. And in this operation, once they start, they can't stop. If they stop, it costs them millions of dollars. And they were having these drives that were running exhaust fans, getting these toxic chemicals out of the operation that kept tripping. But again, they had a power quality monitor telling them it sags, so they spent a lot of resources mitigating sags, but they were still having an issue. Once we got involved with the process, we quickly realized it was transients that were tripping the drives off on DC bus overvoltage. That was causing the issue. And so, again, you can't blame those facility professionals because they had a power quality meter telling them it was a sag event, when in reality it was a transient event that was causing the issue. And it's probably better for another webinar, but transient voltage quantification and dissecting it and understanding it and reading it is very difficult and frankly can be very expensive. In fact, in most cases, from our experience, it usually costs less to mitigate them than it does to detect and track them.
So I would agree with those, Jack. So the other part of the information that came from the survey, around the choices of what causes them is the other thing is you get people who think that, breakers or some other type of overcurrent protective device will provide that, that surge overvoltage protection, and it's not. They're overcurrent protective devices. And so, but another area that the surge protective device does protect is with the motor starts and stops and the switching. We've talked about that internally. Some of it's internal, some of it's external. But these switching events, whether it could be a capacitor switching event at a high speed that ends up sending a transient into the system in lots of different ways, or it could be, something that might be part of an electronics. There's a lot of electronics used in heating through SCRs and different types of electronics that cause these transients to occur with either you have an adverse event or even if you have a continuous process that may not be filtered properly, you'll run into these opportunities as well. And I can tell you the switching events are the ones that can be even the most catastrophic. I've seen capacitor switching cause transformers to catch fire and things of that nature that you need to be aware of. So, as we look at what came from the survey, the two most important pieces here were the correct choices, which were the voltage surges and then the motor activity as well as load switching. So.
Yeah, and I'd be remiss to another misconception out there to not address it. Our industries, SPDs, do not protect against direct lightning strikes. They simply don't. That's a whole other industry, lightning protection system. So I think it's, some folks, 16% I believe, said that that's what they do. Indirect lightning strikes that are coming through the utility and things like that, yeah, you have protection there from our industry. But a direct lightning strike is not an SPD.
One of the things to understand about what drives installation of surge protective devices is if they're doing it when equipment is being installed or a building is being built, it's because they view it as necessary, or it could be part of a building code requirement. Those are the reasons that might be why they would do it, right? They're trying to protect against the things we were talking about, right? Surges, internal events, things like that. That's why they might do it. The things that sometimes people think about is, what will protect and what won't protect. And we've talked a lot about, we'll talk about SPDs as surge protective devices. I mentioned, the breakers and fuses. There's also other things, you can't just put a UPS that we might use for, backup power in, for our computer or our Wi-Fi or something like that. It's not, it's not there as a surge protective device. You may get some conditioning depending on the type you get, but it's not going to, to stop those surges. And then also, Nathan was talking about earlier using a good power strip, as a second level of protection for his computer. A lot of people tend to think that those type 3 surge strips is all you need. And if you don't have anything in which to cut that surge, if a full surge gets to those strips, they're not going to hold up, right? They're not going to protect the electronics. They're a second level of protection.
So Keith and Jack, what can and cannot protect facilities from surges, and what drives their installation?
Yeah, Keith, when I saw these results, I was very disheartened. I mean, it means that other respondents, 62%, are using the wrong thing. And that tells me they're getting a lot of frustration on their end. Or worse yet, they think, well, it can't be surges because I installed this UPS. It's just a battery backup, and I'm still having failures in this operation. So it shows that we, as an industry, have a lot of work to do to educate folks out there about what can protect against transient voltage. So what we typically see when we're with IT customers is they immediately go to UPSs. And while dual conversion UPSs, the really thousands of dollars expensive ones, yes, for sure. But that's not what 99% of people are using. They're using a simple battery backup, which is not going to protect them from transient voltage. Typical power supplies, as Keith said, you have relocatable power taps, which have no surge protection in them. And then, as Nathan said earlier, there are those type 3s that are good quality surge protectors. But again, it's very disheartening to see this. We got a lot of work to do, and we need contractors out there doing some of this work, educating their clients about what risk they have. And then looking at their facilities or their homes, and as you can see, the odds are in your favor that there's an opportunity to educate and help that client protect their assets, whether they're just for entertainment or they're life-saving.
So, Keith, what type of maintenance is required for SPDs, and how frequently should that be done?
So one of the things to think about in terms of maintenance, so SPDs are not, they're not like, a power breaker or a switch or something that's going to require, an annual, checking of the components and greasing of switch mechanisms or checking those contacts and things like that. What what you're looking at here is making sure the maintenance is maybe checking to make sure that the device is still functioning, right? Because a lot of times surge protected devices are put in places that aren't seen visually on a regular basis. So as part of that maintenance, it's as much an inspection on, do you see, is the LED about operational LED still present? Are you having some other type of issue? Is there a discoloration? Are you smelling, some type of, ozone or something like that? So in real general, it's really about, making sure that they're functioning and you don't see anything there with those devices that, could create a problem. You've made the investment. You've got a surge protective device there. It's protected you from, the number of surges that it's designed to protect you from, and it's just sitting there and it's not going to protect you anymore because it's reached its end of life. And that's the important piece there, is understanding if you've reached the end of life that you make the opportunity to replace it, so you don't have, you lose that protection when you think it's there. And one of the things I would say too with that is as the listeners, work with their customers, if they happen to be, doing adding circuits or or some type of maintenance or other activity in the same area as the surge protective devices, that's going to be more in a commercial industrial environment. Take a look at it, right? If you notice that something might be off, the lights, the LED's out, or something like that, then you've got an opportunity to help your customer and create an opportunity for yourself.
So I'll piggyback off that, and I would first say, as a manufacturer, certainly defer to the manufacturer's recommendations of whatever product you have. I look at it as it can be site-specific to a certain extent. What I mean by that is there's products on the market now that have dry contacts that can tie into SCADA systems. I mean, they can text you on your phone. It just depends on the product that you're getting. So each PM for a surge protector is going to be unique to the situation you're in. If you're in a critical asset that it had, like, let's say it's a substation for a utility, protecting some sensitive equipment in there. Well, that's going to be a lot different than someone protecting their gaming system at their house. The point is common sense applies a lot of this. Just like Keith said, take a moment, take a look at it, and is its onboard communication telling you everything's good? Well, great. If you're in a highly sensitive industry, then you might want to add that to your PM rotation. It just depends on what you're protecting.
And I think too, there's not necessarily a counter that says, is it good, is it bad, does it have a special light on it in most cases. And I think, rule of thumb that we say at the foundation is if you're buying new electronics, it's probably time to upgrade to the latest and greatest surge protection available at the time. So I always equate it to, if you're going to buy a new TV or a new computer, buy a second level of surge protection as well. It's not going to hurt, and it's probably worth the investment, and I would say even the insurance to keep that device performing as you'd like, and to see it perform as long as you expect. One of the most common headaches for facility managers is unexpected downtime. So what have you seen, Jack and Keith, from your customers when called to a site? What's some common things that you're seeing when you get there?
So that's a question that's sort of interesting because it can vary a lot by industry. It can vary a lot. Is it discrete manufacturing? Is it process manufacturing? Because you get different reasons and different ways those industries will react to a surge outage, right? Some of them will fail in a process area. If you have a surge outage that fails your pumping system, you have pipes that are now full of sludge, right? Because you've lost your flow. And then in the case of some discrete manufacturing areas, you could end up with, lost memory if you're not, on some industrial computers or something like that, if you haven't properly protected them. So these types of surges can cause those outages. And especially in those particular environments, it's really important. And the downtime is going to be, it may not be the downtime of a fire or something like that, but you can lose data, you can lose, product that all drives, cost to that industrial facility.
So Keith, the only thing I would add is, especially in your manufacturing operations where they're really striving for efficiency because for whatever reason, they're in a tight margin industry or whatever, and they implemented things like OEE or some kind of efficiency program, they maximize a lot of the things they can do. And what sticks out to me in this slide is that, transient voltage is now the third most common cited cause of unplanned outages. So, yeah, we understand we're not accidents, we're not human error, we can't fix those things. But for the person that's trying to get that extra 10% improvement in their operation, transient voltage mitigation is an easy, low-cost way of doing it.
So Keith and Jack, when is it vital for surge protection to work? Based on the survey, we saw some interesting results, but when is it vital for these surge protection devices to really do their job and protect the equipment that's out there?
So Brett, when we talk about, where and why it's important is that when we look at the survey results, right? What we find sort of interesting is, a vast majority of the failed equipment was in service for 5 years or less, right? So what this tells us is that if someone's going to put in new equipment, whether it's, new electronics in your home, new, variable frequency drives or new electronic equipment in a commercial office building or even in an industrial manufacturing facility, if you're going to install that new equipment, you need to put surge protection there, right? Because if you don't, the survey tells us that, there's over a 75% chance that you're going to have an equipment failure, and so due to a surge. And so that's one of the things that this tells us is when do we need that it's vital for surge protection to work, it's on the new equipment. Because, while it's always good to put it on any equipment, what the survey's telling us is that the newer equipment is more susceptible to surges, as we talked about, in some of the earlier discussions.
If I can add to Keith's response, which was spot on, and I'm going to talk a little bit about this when we talk about the timeline and how the NEC is evolving, but a lot of the equipment that's being installed by contractors today and being used in essential electrical systems and emergency systems, a lot of them have integrated electronics as a part of that type of equipment. Fire pumps is another example. And when you're talking about equipment having to be resilient and having to have continuity of service, surge protective devices are directly related to that type of equipment remaining operational. Emergency system panel boards and switchboards, many of the new generations of equipment have electronics in it. And if those systems were to fail, we're talking about life safety systems for a building, getting people out of buildings and things of that nature. So it's there's a lot of evolution going on that's resulting in requirements for surge protective devices. And while many owners and the general public may see it as additional cost for putting equipment in, it's also very essential to make sure that equipment performs properly, even during a surge event, or continues operating after a surge event. So that brings me to a segment that I thought would be important to include in this presentation, is to talk a little bit about the brief history of the NEC and maybe provide a timeline for the audience on what happened, when, and why. And when you look back at the NEC several editions, and when I started in the field, I started in the early editions, the 70 editions of the NEC, 71, 75, and it's hard to believe we're coming upon 50 years. But we started seeing mention of surge protection in Article 230, Article 501, and 502 in those early editions, but it was mentioned in a fashion that if you install it, you do these things. So it was treated as an option at that time. So mention of it in the NEC was included. When you look at the NEC, the introduction talks about the protection of persons and property from the hazards that arise from the use of electricity. And what's happening with the requirements related to SPDs plays right into the property statement in that clause in 90.1. So as the NEC evolved into the 70s and 80s, we saw Article 280 appear, and Article 280 was first titled lightning arresters. And while it kind of made sense what they were trying to do, that's just an external cause of a surge event. The NEC, under its current scope and the scope then, was never intended to provide lightning protection or the rules to protect against those events. There's another standard, NFPA 780, that talks about that type of protection. And when you get into that standard, it talks about having to install surge protection for a completely installed system that has a master UL label on it. But in the 80s, in the 78 to 81 edition, the term lightning arrestor, as the title of Article 280, was changed to surge arresters at that point in time. And in that article, under surge arresters, both surge protective devices and surge arresters were covered. And up until about the 2002 edition of the NEC, that's the way the code addressed it. And in the 2002 NEC, the evolution started happening a little bit more aggressively. And that's when Article 285 was first developed. And that article aligned right up with Article 280. So we had an Article 280 for surge arresters, Article 285 for surge protective devices. And then from about 2005 to the present day, what we saw is an incremental progression of inclusion of mandatory requirements for surge protective devices that are appearing in the NEC. When we get to the 2020 edition, which is really where we are now, we're on the edge of issuance of the 2023, but we're not there yet. But the 2020 edition of the NEC actually combined both Articles 280 and 285 and changed the title to Overvoltage Protection. Another thing that happened is responsibility of the new article was redirected to Panel 10, and Panel 10 covers primarily overcurrent protection, so it made sense that that they deal with the overvoltage protection as well. Panel 5 dealt with Articles 280 and 285 up until the 2020 edition of the NEC, and we're waiting the issuance of the 2023. I don't believe there's very much change at all that happened, but there may be some additional individual requirements for surge protective devices sprinkled throughout the NEC.
And I would add, to kind of close out this webinar, that, the world is quickly evolving, and, Industry 4.0 is upon us. Energization of everything is around us. I mean, I look around the room that we're in with the lighting and the thermostat and the HVAC controls. All this stuff is definitely more sensitive than it ever was in the past. And we have to make sure that we're protecting as best as possible. And I think, some of the pushback that we get for the expense and added kind of headaches when it comes to installing SPDs, a lot of that stuff, once you kind of put it in context, it does make a lot more sense and why we're doing it. And it's really to protect the equipment that's out there. And it's just more sensitive than it's ever been. It's smarter than it's ever been. We need the data more than ever from these smart devices. And the idea of, why ESFI is involved in surge protection and why we think it's so vital is the fact that, safety comes in many different forms. And it's kind of a trickle-down effect. So where we're trying to keep, things active and making sure that things are resilient as possible, we want to keep people out of harm's way. And so utilizing Industry 4.0, the data that provides back into the system, making sure that life safety systems and vital systems like that are online as much as possible, that's going to keep people out of harm's way. And that trickle-down effect to maybe where that traffic control, has an ambulance going through that intersection at the same time as a car, all that stuff boils down to making sure that these devices are working well with each other and they're working as they should. And SPDs only provide that level of insurance that I think all of us kind of expect with some of these smarter devices that are out there. And that goes for the residential side as well as the commercial and industrial side. Things have changed, and we need to adapt with those changes and make sure that the equipment's protected and give us the level of insurance that we would expect.
Yeah, Brett, excellent points. The resiliency and achieving higher degrees of resiliency is really important. And I think the NEC committees overall have done a great job of keeping the NEC relevant. It would be a shame if we didn't have requirements that were directly related to life safety systems and other systems that need that type of protective feature, so we don't have damage and disablement of those types of equipment with sensitive electronics.
And I think it just bears to say again that many of you all know this on the call or on the webinar, but this is a standard. You can always increase the standards. You can always do better than the standard. This is trying to keep everybody on the level playing field, that they're working off of the same documents, but you can always do more. And so those repetitive steps that you take is only going to give you that much more protection.
So if we can expand on the comments we just had about the NEC and the evolution of the NEC. some examples of rules in the NEC that call for surge protection can be found in Articles 620, dealing with elevators, 645, dealing with information technology equipment, 670 deals with industrial systems and equipment, 694 is wind turbine systems, 695 is fire pump systems. We've got Articles 700 dealing with emergency systems, and 708 deals with critical operations power systems. All of those are systems that require that type of protection, and now there's rules within those articles that call out surge protective devices. And Annex G requires surge protection for those types of systems. So it's in a state of evolution. It's a work in progress, and I don't see it slowing down the development of rules in the NEC. It's responsive. The NEC is responding and remaining relevant relative to that protection. So that brings us to the end of the presentation portion of the webinar, and we have time for some questions and responses. So at this time, we will turn it over and see what we have in the chat feature, or respond to any questions that may come in for those attendees that are live.
And I would just add, please ask your questions, provide your feedback, because this is hopefully going to be a series of webinars that NECA and ESFI team up on. But if we can't get to your questions now, we will have one of the experts follow up with you directly to answer your question as best as possible.
All right. Thank you so much, everyone, for that fantastic discussion. So for those of you who have questions that haven't submitted them yet, go ahead and add them to the Q&A box on the bottom left of your screen. So let's get started with the first question here. What kind of resources are available showing the quantitative values for like savings that managers and owners can look at to make an educated decision to justify the expense of installing a robust SPD system? Can anyone take that question?
Sure,
Okay.
I can take that one. So that is a question I spend the majority of my time answering day in and day out. And I think it's George that asked it. George, you're probably not going to like the answer, but bear with me for a second. The first thing, and I alluded to this earlier, it's really expensive to track transients through power quality monitors. You're looking at between 10 to 20 grand per device that you're going to put throughout your facility, but that's only half the battle. So you're going to see the transients. You can go through, read the trilogy at IEEE or thousands of other documents to see if they exist. But then you have to connect that to your failures. And the majority of these failures, as we've seen through IEEE and NEMA, are originating from transients within your facility. And the key word there is transient. It's not happening normally. It's an abnormal operation. So again, it gets really expensive. So there's the bad news. The good news is ESFI has done some great work here quantifying what your peers are seeing. And I know we have our own data sets looking at A/B analysis. Schneider, Eaton, any SPD manufacturer is going to have that information. And so you can take that information, look at your facility or your operation, whatever you're doing, and we've seen people, that's enough for them because it's physics, it just exists, and they move forward with that robust system. And we've seen others that say, well, I want to test this out and do A/B tests. It's whatever your ownership feels comfortable doing.
All right, thank you. We have another question. So when looking at type 1 and type 2 SPDs, do they protect residential AFCI, GFCI breakers?
So Colleen, I'll take this one. So both GFCIs and AFCIs do have internal MOVs that protect the devices. However, the additional protection that a type 1 or type 2 SPD will provide will increase that protection from higher levels of surges, even beyond what those products are required to do within their individual product standards. So they are going to help protect those devices at a level even higher than what they're designed to protect themselves.
Okay. Here's another question. So far, the issue with transient surges is for equipment, but how does it affect the safety of workers and people?
I can answer that one. It's really indirectly related to protection of persons within facilities, as it is directly associated with equipment remaining operational in an interruption of service or in a surge event that would possibly disrupt the electronics in a lighting system that is necessary in paths of egress to get people safely out of a building during a power interruption event or something of that nature. Those systems are required to operate for at least an hour and a half, if I recall, but thus the requirements for surge protective devices on those systems appearing in Article 700 in recent editions of the NECA. So it's indirectly related to keeping people safe by providing the minimum light levels in those egress paths when those events occur. And if I could, Colleen, the very first question, where could information be found about that would justify the investment for SPDs? You can go to several websites on the internet. One of them is geology.com, and there are others that can provide a pretty extensive map on where the heavy lightning events occur around the world. And that could be another indicator or litmus test for someone trying to make those decisions. Those, of course, are the external events that we talked about, but they may weigh into whether or not a facility invests in the SPDs.
All right. So how do SPDs affect the category rating of portable test equipment according to IEC 61010? So if they're engineered in a distribution system, can the CAT rating of test equipment and leads be reduced? Is there someone that can answer that question?
Colleen, I think that one might need a little bit more research. You know, the category rating for test instruments can be somewhat related to surge protective devices, but it's more related to the equipment being used to verify absence or presence of voltages. We need a little more time to make sure we get an effective answer and an accurate answer. And so we'll respond by email for that one.
Okay. And the person who asked that, you can also send your question to safety@necanet.org directly if you'd like. Are there any newer technologies than MOVs for type 1 and type 2 SPDs?
touch base on that one. So I think what I would want to say is that there's a lot of hybrid technologies out there that's not just relying on an MOV or a thermally protected MOV, using diodes and capacitors into a hybrid circuit. So I don't want to necessarily say yes, because it's different. I would say it's different technology going towards the same goal. So I hope I answered that question. Are there newer technologies than MOVs? I wouldn't say they're necessarily newer, but just realize that there's others out there using hybrid circuits, and they're widely available.
Mm. We had another question about MOVs, actually. Are they one-time? I'm not sure what the person meant by that. Maybe one-time use?
I think I know what they're saying. Keith can comment on this one too. Well, the answer is depends. Depends on the surge event that it's trying to mitigate. Typically, no. It takes a very large surge event, transient voltage event, to knock out an MOV. I'll just leave it at that. I mean, it just depends on the environment that they're in and what they're seeing and what they're mitigating their equipment from. Obviously, the more severe event, the shorter its life. But these things can take thousands of internally generated transients, more than thousands, millions. Keith, you want to add to that?
Yeah, so thanks, Jack. Yeah, this one, you know, the it depends statement makes a big difference. The MOVs, which are part of the SPD, you know, are designed, you know, to take certain levels of surges based on the ratings of the device being selected per the product safety standard, right, per the UL standard. And so those, so it's going to depend on the level of surge, you know, that, and that's what's going to drive, you know, the life. It's going to be, you know, what the size of the surge is. And, you know, is it going to be a lower level surge that's just going to continue and continue to be chopped as we would expect, like Jack was saying, or if it's a very high, you know, high magnitude surge, you know, then there's certain, you know, tests around how many of those that an SPD can take in its life, and those devices have indication on them to if you've hit you know, multiple ones that do cause a failure. So.
All right. Well, I think we have time for just one more question. I know we're running a little long today, but this is just so fascinating that I didn't want to let up too early on the questions. So maybe one or two of you can weigh in on with your thoughts on modular versus non-modular SPDs. Nathan, we haven't heard from you yet. I don't know if you want to weigh in.
That is kind of outside of my area of expertise, so I can't help much with that. Probably one of the manufacturers would be a better source.
Well, so, I mean, I'll make a couple of comments here is that you have, you know, there's different types of, you know, when you talk about modular versus non-modular, it depends, right? In our case, we actually have both. Our larger ones are not, and some of our DIN rail mounted stuff is. So it kind of depends on the application that you're using, and as long as it's met the product safety standards, you know, I don't think you're going to run into too much of an issue as long as it's been the units you're using has been tested and certified.
Yeah, I agree with that. I think that that particular feature is not a performance feature. It's more of a convenience feature, I would say. And so it would be secondary to making sure that you're selecting the device with the proper metrics that are going to protect the equipment that you want to protect. And then after that would be you want dry contacts, does it need to be modular, what type of enclosure, 4X, 3R, things like that. So I don't see it as a performance metric. I see it more as a convenience metric.
Okay. Well, what I'm hearing with a lot of these things is it depends. So apparently working with experts is definitely important for this kind of thing. So I want to thank everyone for your time today. This was a fantastic discussion. And I feel like I learned a lot. I'm sure our attendees did too. So on behalf of Electrical Contractor and ESFI, thank you everyone for attending. And thank you to everyone, moderators and panelists for the discussion. So for all our attendees, please don't forget to fill out the survey. It should pop up at the end of when I close the webinar out. Just a few questions. We'd love your thoughts. And please be on the lookout in your email for a link to the recording. It should arrive later today, I believe, or tomorrow. So we hope you have a great rest of your day, everyone, and thank you for your attending.